Guys, it's 8.2, explaining the major features of the solar system, which means we're going to be talking about those three things and the exception, okay, and why the nebular theory proves those things, okay? So let's go into it. The first one, the orderly pattern of motion. Okay, so why do they all orbit counterclockwise, and why do they pretty much all rotate counterclockwise? And remember, the moons around these things, the major moons, the large ones, also orbit counterclockwise. There are some like smaller captured comets and asteroids and things that don't orbit counterclockwise, but the large ones that look like they formed in the solar system with the planets and the sun, they all orbit counterclockwise as well. Remember, the only exception to this is Venus, and the only exception to the large moons is Triton that goes around Neptune. Those are the only two exceptions. Okay, so remember, we got to ask, why is this? We got to answer, why is this? And then answer, why are those exceptions the way they are? Okay, so the first thing, so why are they all orbiting counterclockwise? So remember, we came from a nebula. Okay, the idea is we came from a nebula. The nebula collapsed. Okay, when it collapsed, it heated up, because remember, all the particles are now tightly bound. That means they heat up. Okay. And also, they begin to spin, okay? Because all of them are spinning, okay? The nebula, none of the particles are just sitting there. They're all moving. And when you bring things in closer and closer, they will spin faster and faster, and it also heat up, okay? A good way of thinking about it is get one of those little chairs that spin around in a circle. Hold something outside, and you spin yourself, and you go slow. And then if you pull those things inside and you're still on that same spinning chair, you'll start rotating really fast, okay? So the closer you bring things to the center, the faster it will rotate and the hotter it will get. Okay, and that's how our star created. In the middle of that was the star. All around the sides were the things that will eventually be planets and asteroids and comets. Okay, now, when these things come together like this, obviously, all the particles are now closer together. They're going to start running into each other. They're going to be beating each other up, right? Okay, well, when they start colliding and running into each other, they all start to form a motion into one direction. As the larger mass, the more average amount of particles that are moving counterclockwise, they start making everyone else move counterclockwise by running into them and pushing them and things like that, okay? So collisions between all these particles is what makes it to start to move in a counterclockwise direction. Remember, every solar system might be going a different direction, okay? We have a solar system that's flat and orbits counterclockwise. All the solar systems will be flat because as they start spinning, flatness is just inevitable because of the collisions and everything. But maybe in other solar systems, everything rotates clockwise because the average particles are moving in a clockwise direction than a counterclockwise. So the collisions is what flattens the disk and makes it move in a counterclockwise direction. That's why everything in our solar system moves in a counterclockwise direction, basically, is because all the gas that made it up moved in a counterclockwise direction. Okay? So, why are there two major types of planets? Why do we have terrestrial closer to the sun and Jovian further away from the sun? So we realized that the terrestrial were closer to the sun, right? And then the gas planets were further away. We found out in between Mars and Jupiter, there's this thing called the frost line. And so inside of the frost line, over here, it's too hot for hydrogen compounds to form ice, okay, to form solids. So you're getting gaseous forms of hydrogen and things. Outside of the frost line, you can have hydrogen compounds forming, making solids. What that means is outside of the frost line, if you go further out, you have more material to build planets. Because now you have all these hydrogen compounds, which make up most of the universe. So we have a lot more stuff out here to build planets than in here. In here, they have to be made out of rocky and metal materials. Out here, they can be made up of hydrogen compounds plus rocky and metal elements. So that's why past the frost line, they're going to be larger planets. Inside, they're going to be smaller because there's less material to build them. Okay. Okay, so how did we get these planets? Okay, so it's called, you need to know this. You need to know two words here. Planetesimals and accretion. Okay, so when all these gases, let me go back to a couple slides before here. When all these gases in this cloud came together, okay, when all these gases in the cloud came together, when the collisions start forming, if those objects are solid, they'll clump together, right? So after a while, they started clumping together and making small little objects that are all orbiting around the sun. Okay? Then those smaller objects, these are called planetesimals, okay? Planetesimals are basically asteroids, but before there was planets. Call them planetesimals. Once these planetesimals started running into each other and making bigger rocks, then we're having larger planetesimals orbiting around the sun. Then these larger planetesimals started colliding into each other, making large rocks that we now call planets. Okay, and that each one of these planets orbit in their own celestial zone. Okay, so that means like they've cleared out all the planetesimals in their orbit, and they created a planet out of it. If something has not done that, then it's not a planet, and that's like Pluto. Pluto hasn't cleared out all the planetesimals in its area. That's why there's the Kuiper Belt out there. It's a bunch of planetesimals or comets. Now that we're past the planetesimal era, they're comets, and Pluto wasn't able to gather all those comets and make it one big planet. Okay, that's one of the rules to be a planet. You have to gather everything in your little orbit, and you have to make one giant spherical object out of it. And we call that accretion. Accretion is the ability to grab all the planetesimals and accrete them together to make a planet. Okay, so you need to know what a planetesimal is, and you need to know what accretion is. Planetesimal are basically asteroids from before there was planets, and they accreted together to make planets. Okay, so how did the Jovian planets form? So, we already spoke about that. Past the frost line, there are more molecules, more things to make a planet, and then once it makes that stuff, it'll be bigger than the terrestrial ones because it had more things to build it, and now it has a larger gravitational pull, so it's able to pull all the hydrogen and helium gas towards it as well. Okay, so then it makes these planets so much larger than the terrestrial ones ever could have been. Okay, so here is remember we call it the nebular theory because we have a lot of stuff to back it up. Here's an image of a current solar system going through the accretion process that we're talking about. Look at all the red stuff are planetesimals, which will eventually be planets. Notice how they've got their own little zones. So this is one planet, you're going to start accreting all the planetesimals. Same thing here, same thing here, same thing here. And this is a solar system, in-birth solar system beginning. Remember, this is how we know these things are true. We can see it going on in the universe in different areas, and we put these little images together to form a full life cycle of what a star or a solar system would go through. Okay, where did the asteroids and comets come from? So this one's easy. If we said that the planetesimals accreted to make planets, well, not all the planetesimals would have accreted into the planet. Yeah, so we have like zones, like in between Mars and Jupiter, where it didn't accrete into one planet. So they're all asteroids. They would have been called planetesimals back in the day. Now they're asteroids because we have planets. Because it was never able to form a one full planet. And the reason why it wasn't able to is because of Jupiter's gravity. Okay, so if you're wondering why. So what these asteroids and comets are they're leftover planetesimals. Okay, so then we need to have exceptions to all these things. Like, okay, well, most things orbit counterclockwise. Why does Venus not? You can't just say, oh, well, not always like that. No, you have to have reasons. And the reasons are these planetesimals run into things, okay? It's a giant mess of rocks, okay? A rock can easily run into something and ruin like the whole pattern for certain planets, like Venus. So it would orbit counterclockwise, except we think a giant thing ran into it in the past and flipped it upside down. And if you have something that's rotating counterclockwise and you flip it upside down, it looks like it's rotating clockwise, okay? So we think giant impacts are the cause of a lot of these exceptions, okay? So let's just talk about some of them. So now remember some of the moons we're talking about. A lot of moons are that orbit clockwise, go opposite, are captured planetesimals from the beginning, captured asteroids and comets. Like Mars has these two tiny little moons called Phobos and Deimos, and they orbit opposite to the direction that we would assume. So they go clockwise. And the reason why is because they were captured. So they were just floating by, and Mars gravity grabbed them and they started rotating in whatever direction that they were kind of captured in. So it wouldn't have had anything to do with being created during the beginning of the planetesimal era. So how do we explain our gigantic moon? Like all the other planets don't have this gigantic moon. Well, we think it was a large collision. It was a collision with a large planetesimal in the past that was probably near the same size as Earth, maybe smaller, and it collided and it kind of blew up a little bit in a lot of different areas. And then as that like debris came back together, it came together as the moon and it came together as the Earth, and we have the moon orbiting the Earth now. Okay, so obviously the Earth would have been the larger object in this collision, and the other one quite a bit smaller. Maybe it had a lot of a collision with it, and a lot of debris came off of it, and it's kind of stayed solid. Or maybe that debris coalesced to be the moon. Okay, but it's from a collision. Okay, giant impacts may have knocked some of the planets off of their axes, just like Venus, like we said. Remember, Uranus orbits like on a 90 degrees axis, which is kind of weird. We think that's from some sort of collision during that planetesimal era. And that is everything for the exceptions. So that's 8.2.